A little while back, in my previous video with the Wi-Fi cup, I used an ESP8266 to drive some WS2812s. It worked, but it was awful. I have since gone back and fixed it up a lot though. So now it's a much better driver. That's not what this video is about though. This video is about how you can, with an ESP8266, drive all sorts of devices and have an internet connected without having to have another processor like an Arduino or an AVR in the mix. So if you're curious about how to compile your own programs and build them and burn them for the ESP8266 without trying to read through pages and pages of forum threads, this video is for you. So when you want to go start doing a lot of stuff with projects, Git is kind of the flavor of the week right now, and most of the things you're going to need are on GitHub, including this, my ESP8266 WS2812 driver. And here I actually have the step-by-steps on how to do this. So I'm going to be actually reading from here to do the video. I made a ESP8266 folder in my home folder here, ESP8266, that doesn't have anything in it right now. And I have a Git folder, which is where I keep my projects. Not right now, I've kind of cleared it out for the video, but it's where I put them. So the first thing we're going to do is we're going to check out this particular repository to my Git folder. So git clone and then the URL. GitHub is really convenient that whenever you visit any Git page, you can just go right down here where it says HTTPS clone URL and say git clone and then that thing. As a side, I forgot to mention that I use Linux, so I have no idea how you would do this in Windows. In Linux, it's just easier. So I just use Linux, and that's where we are. I use Linux Mint. I guess any of the other Linuxes would work, but you know, whatever. I'm Mint. It works. So I'm going to go clone the GitHub cnlore ESP8266 Git. Okay, so now I have in here a copy of my WS2812 driver. If I type make, it's not going to work. It can't find the compiler, and it's not going to be able to find any of the other stuff. That's okay though, because now we can go get a copy of the compiler. So now we're going to go get the compiler. So we need to get GCC and some of the tools that come with it. Conveniently, JCMVBKBC, I have no idea how he wants to say that, has put together most of the stuff we need. And I'm going to make a ESP8266 folder. Right now it has nothing in it. So that's the first step, is to cd in there. Then I'm going to go clone his extended toolchain build. So let's go get that. And now it's going and cloning all of his stuff. I'm going to go cd into it, and I'm going to have to go get some of the other files. So in here, he has all of the build scripts that are necessary, but he doesn't provide a copy of GCC, GDB, and a copy of the binutils. So we're going to go get those right now. So I can just wget the one file, gets this straight from GNU, and we're going to go into turbo time. Okay, there's the first part of the compiler. Now what we're going to have to do is get a copy of GCC itself. So that was binutils, and unfortunately we have to use a special branch of GCC to do this. The processor just has a couple little weird parts. Conveniently, he has also branched a copy of that, and right here I can go clone his repository of that branch of GCC. This takes a while longer, so we're going to have to really go into turbo time. Alright, so now we have GCC Extensa, and we do need to rename it to be the thing that it needs to be. These instructions aren't quite right. I'm going to go change them in a second, but they will be right once I'm done with this video. So I'm going to say mv GCC Extensa GCC 4.9.1. So that way his scripts will know where to get it. I also need to get a copy of GDB because by default his stuff makes it, and I figure, well, why not throw it in for fun? Okay, turbo time! Now we have most of what we need. We just need to prepare for the LX106 architecture. Thankfully, he has a script for that. This script goes and it untars the bin utils and the GDB. It notices that it already has GCC, so it doesn't do anything with that. And it applies any of the patches that were necessary to make it even, get off the ground for running on the ESP8266. Now, we're going to have to go build it. So, if you say this, if all goes well, it should just crank out a copy of GCC. Yeah, back to turbo time. Alright, so the compiler succeeded. This is particularly good news. It means that we might actually be able to go do this thing. The other few things we're going to need is a copy of ESPtool to handle the binaries and ESPtool.py to handle pushing the image, and we will also need the SDK in order to go build our thing, because the SDK is what helps you have all of the nice little functions that make talking to the internet and Ethernet and everything else oh so easy on the ESP8266. So, for the ESPtool, we're going to have to go and get a copy of ESPtool from, well, I don't even really know where it's from. I'm sure if you Google it, you can find the person who made it. So I'm going to just paste all that in. See the ESPtool, and now in here I have makefile. So if I edit makefile, I'm going to change it to Linux for the target arch and make. Now I have a file called ESPtool, which is exactly what I want. Now next I'm going to need to get a copy of ESPtool.py. This tool by default uses 115200 for the baud rate. You can go faster than that. I've only ever really tried twice the baud rate, but I think you can go faster than that. I think somebody said you can download code to the ESP8266 at 0.5 megabit, which is pretty quick. So, oh, there's another bug with that. So here, with the ESPtool, we can go clone this Git repository too. So let's go into ESP8266, Git clone, and the ESPtool. So now if I look in ESPtool, I have ESPtool.py. Now we can edit ESPtool.py and change it to 230400. So we go even faster. Okay. The last part of getting things for this is going to be the SDK. So I have that, and just copy and paste this here. It gets these from Espressif's actual website off of their forums and saves it to the appropriate files. There's two files. One is the base SDK, and another is a file that they updated. I don't know what was wrong with the original, but they said use the new one, so by golly, that's what I'm going to use. So let's see here. Let's just paste that in. Okay, it's downloading the main SDK and the patch, and it unzipped the main SDK and we will have to overwrite that file in the patch. Okay, now in here I have ESP IoT SDK 0.9.3. So these are all the files you actually need to go build your projects for the ESP8266. So if I go back to Git, and in here WS 2012 ESP8266, the original repository we downloaded, and I type make, bam! I actually can't believe that worked. It popped out a little image.elf. The next thing that we're going to need to do is say make burn, and one thing I forgot to do is to put the ESP8266 into program mode. Let's do that again. Oh no, what's going on? For some reason, I don't know what causes it. Sometimes I can't really flash it at the full speed, and I do have to go back and edit the ESP tool.py, and I have never had a problem at 11520. I have no idea what would cause it to fail at the higher speeds, it just sometimes does. Oh, yes, have to put it back into program mode. Okay, now we are cruising. You should experiment with other speeds, but 11520 should work all the time. It's right now just flashing the chip. Bam! The chip is flashed. So let's go see that again from another view. So my setup here is a little USB to serial adapter. Any of these will do. Make sure that it can do it 3.3 volts. Originally I was actually using the onboard 3.3 volt adapter, but it turns out something's wrong with it. I guess maybe I damaged it at some point. So I'm using this Power over Ethernet enabled AVR do everything boards 3.3 volt regulator right there as a stand-in. So I have the adapter here, and I have an ESP8266 here wired up to 3.3 volts. And on the ESP8266, I've tied several of the pins together to VCC, and have that with a capacitor to ground, a resistor over to GPIO 0 as well. A little switch on it that if I click and reseat the reseat the ESP8266, it will boot up in the bootloader mode. And to all of this, I have a bunch of WS2812 LEDs. So, what we're dealing with right here is the USB to serial adapter, the ESP8266, WS2812s, and of course CHPD, RST, and 3.3 volts are all hooked up to the 3.3 volt rail. GPIO 0 is hooked to the switch, so if I click it, it's held to ground, which causes the bootloader to go. If not, current will flow through the resistor to 3.3 volts, pulling it up. So, let me show what happens when we put this thing into bootloader mode. So, let me show you how to put this into bootloader mode. You unplug it. I can click the switch with 2 fingers, and with the other 2 fingers, I can go plug it in, which puts it into bootloader mode. Then, over here on the computer, whoa, you can see it flashing away rather quickly. It turns out it was the 3.3 volt regulator that made me not able to flash at full speed. And now, the very first thing it does when it wakes up is turn on these green LEDs, which means, hi, I'm working. So, oh yeah, that's also another annoying thing, is that the wires keep falling out there. Let me go reset my Wi-Fi, and it should come up and automatically try connecting. Oh, hey, look at that. It already found it. And let's see if it's pinging. No, I guess it hasn't found that. Let's try that again. Oh, it's trying. It's trying. There we go. Oh, missed that. Sorry. bad camera work. So now you can see that it's connected and pinging the ESP8266 quite proficiently. By the way, that's my laptop's fault. It does it on every network, and I have no idea why. Just every now and then. So now I'm pinging the ESP8266, well, my custom program on it. But that's nothing new. What is new, however, is the fact that I can now use this over here to go and send it WS2812 commands. So I'm going to go run the last top command, which says send to 192.168.4.1 100 lights. I only have 15, but that's okay. 15 is more than enough to check this out. So I'm sending the lights over by Wi-Fi, the network, into the ESP8266, which is then sending them out to all of these WS2812s. I hope you guys liked this video. If you have any other questions, please check out the ESP8266 forums. I've put the link in the description right below.